Okay, this is Eric Vanderwall, and we're looking at the substrate recipes, and these may have changed or not have changed from when I've recorded this to when you're looking at it. That's okay. I think you're gonna be able to follow along anyways. In this, we're using Framework 1, so this is a good place to start because a lot of Substrate is still using Framework 1 versus Framework 2, and it's going to give you an understanding of how it works. Now, the Hello Substrate palette here is basically about printing the node log. So this is about printing essentially debug statements. And this is really useful as you go along and you need to potentially print out debug statements to yourself in your node log. And let's see here what it says. This palette has one dispatchable call, so essentially one function that we call from outside the chain that prints a message to the node's output. Printing to the node log is not common for runtimes, but can be quite useful when debugging and as a hello world example. Because this is the first palette in the recipe, we're also going to take a look at the general structure of the palette, so that's good. So let's go ahead and just go through this directly first, and it says no STD, no standard. So the very first line of code tells the Rust compiler that this crate should not use Rust's standard library except when explicitly told to. This is useful because Substrate runtime compiles to WebAssembly. So this will sometimes be written as WASM, W-A-S-M, if you're not familiar, where the standard library is not available. Okay, so the standard library is not available in the WASM runtime, and we're not really using the WASM runtime at this point while we are developing things. We are essentially using the native runtime, but we should keep in mind, what will happen with the WASM or what will be compatible with it for later down the road. So essentially, this is going to be written at the top of every palette. Now, the next thing that comes after this is the import statements. And these are just all essentially use statements, and they're going to tell us, or tell the palette what things they need to bring into the palette that we might need to use. It's going to bring it into scope. So this is similar with how Rust works. There's nothing sort of unique about this as far as I know. So these are the imports that we're going to use. We're going to use from the frame support. We're going to use some submodules or modules as of debug, declare module, and dispatch results. And so we'll look at this as we go through it, what these mean. But essentially, debug allows us to do some sort of debug statements. Declare module means that we have a place to call a function. And dispatch for dispatch results allows us to return some sort of result from the function. Okay, we also are going to use from the frame system the ensured signed module, which we will also look at. And we'll look at this, but I don't actually use this, okay? So this is the use sp runtime, and it has a print statement. We're going to look at the print statement, but and then it does tests. We're not going to look at tests today. And so let's talk about the configuration trait real quickly. So next, each palette has a configuration trait which is called config. The configuration trait can be used to access features from other palettes or contents that affect your palette's behavior. This palette is simple enough that our configuration trait can remain empty, although it must exist. So every palette, again, has to have this configuration trait, even if you're not actually using any traits. So you're going to learn about the traits as you go along and learn the different palettes. But for now, I don't think it's worth explaining just because it's going to sidetrack us from what we actually need to know, and we're not using any of them. Okay. The next thing we have here is we're going to use this macro statement in the code called declare, or DECL underscore module with an exclamation mark. And this is what Rust calls a macro, if you're not familiar with it. And what it does is it takes in some code and it reads this code in its own unique way that isn't necessarily in Rust format, and do a bunch more behind the scenes that we don't necessarily need to worry about up front. So it's going to do essentially some magic behind the scenes because we don't want to sort of rewrite the entire function of this declare macro every single time we want to make a palette, because that would just be a lot of work. Okay, and so they're calling this dispatchable calls. But essentially, in my mind, this is a function on the blockchain, or it says here, is a function that the blockchain user can call as a part of an extrinsic. And extrinsic is substrate jargon, meaning a call from outside the chain. So we're going to look at how to do that, don't worry. And then it should make more sense sort of as we do it, and you can be like, oh, okay, that's what that means. Okay, so most of the time these are transactions, and that's usually the case. Okay, so we've declared the module, and then the first line of every module is going to be like this, or within the declare statement, it's going to say pub struct module, blah, 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 blah. But essentially what this is going to do is get the caller, the person who's calling any function, and find out who they are. And we're calling it here the origin of this function call. So we're going to look at this, but this should be some sort of a user like Alice or Bob or whoever else. And we want to make sure that it's someone legit who's calling this function and not just sort of a random person, or it's going to be spam, or someone's going to try and hijack, and that's what it's going to do. So we're adding a weight, and I'm not going to talk about weights now. We'll talk about this in another lecture. But they've just set it to 10,000, and that's fine. You can set it to whatever for now. And then we're going to declare a function. And so this is essentially standard Rust formatting. So we've got public, because it's a public function, fn for function, the name of the function, and the first variable, or the first parameter that this function must take in all palettes, or should, is origin. So where is this coming from? It's actually coming from up here. So that's why we always have this line, and it doesn't need to change for any palette. Every palette's going to be the same. And then just like every function here, it's going to return the dispatch results. Okay. And then they just say snip here because the code would go here, and you could have more functions below this. Okay. As you can see, our hello substrate palette has a dispatchable call that takes a single argument called origin. The call returns a dispatch result, which will either be OK, indicating that the call was successful or succeeded, or an error, which is demonstrated in other palettes here that we can look at later. So I'm going to skip the weight annotations, and then say, okay, let's look at our call further. So we're going to do that in code. And you can go ahead, and you really should go ahead and read this and see what they say. Although some of this I feel is a little bit out of date. Like, for example, how we call our runtime is not really the same anymore, I don't think, and some other stuff. So let's just go ahead and jump into the code, and then we'll sort of figure it out from there. Okay, and to find this palette, I've got the substrate recipe, GitHub forked, cloned on my system, opened up here. I'm using IntelliJ IDE. You could be using Visual Studio Code. We're going to go down to the palettes, open up your palettes, find hello substrate. Mine are alphabetical here, which is nice to find H. Open up the source and open up the library. So again, you're going to find in here also the test, which we're not going to be using, so don't worry about that for now. We're just going to look at the library. So just as we talked about before here, we have a little configuration attribute here that says we're not using a standard library, so please, don't do that, right? Then these are our using statements, which are going to bring things into scope. This is declaring the test, which we're not using test. And then here we are, we've set up our traits for this. And again, we're not using any traits in this, so we're going to go over that later, but it does need to be here, otherwise it's going to throw an error. Okay, so let's look at the meat of this. And mine is a little bit different than the one that you're probably looking at if you just downloaded the original version. And I made a couple of changes because I wanted to make this, I think, more simple and a little more up to date. But so this is the first function that they have, which is a function that says hello to the users by printing messages to the node log, right? And so the first parameter that's passed to this function is origin. And pretty much every palette, unless there's a very specific reason to, is going to ensure that the origin is signed correctly, that this is someone who should be allowed to be here. And we have a little question mark here, which says, if this fails, then we're going to throw an error, and that's going to go up the chain here and into the dispatch result and say error. and we're going to exit here. We're not going to continue going. So if not, let's just save the caller. So I'm going to add a little beep, little underscore here, just to tell the compiler that we're not actually going to be using this variable, but I have it declared anyways. Okay, then we have a print message that just says hello world. And we want to indicate OK when this call was succeeded. Okay, now my understanding is this: the print statement has become legacy. There are other ways to write to the node log that don't include this print statement, which gives us more control over how we're going to send out to the log. So I've included it here, and we're going to see how it works, but I don't want to really dwell on it. But it's a very simple macro, and it probably looks very familiar to you as like the print line statement, right? But we're not using a standard library, so we can't just like print a line if you're familiar with Rust. Okay. Now I'm going to go down to right down here. Actually, you know what? Let's just do this one first. Okay. We want to actually call our debug statements using this debug, and then we have various levels of debug calls that we can have. We could have an info call, a debug, an error, a trace, a warn, and essentially these are just different levels of calling the statements, and they're going to display in different colors in the console. And whatever the highest level you call, every level below that should also appear, I believe. So we'll have to double check that. But for example, if you call debug, everything below that should call, which I think is everything except for trace. Trace is, I believe, the highest level. And let's just go up to the top. So you can see here that it's coming here from this debug palette, or sorry, the debug module, which is part of the frame support palette. That's where this is coming from, this debug. And in order to write this, we just need to write debug, little w dotties, and then we can say, if we want warning, and then it's a macro, so we do need to end with exclamation mark. And then we have opening, closing parenthesis, and we need to put our data in here. Okay. And we can pass this a value. We can pass it a variable. So this is just like how we're going to call this in Rust. So for example, debug info, and we can say this request was sent by, and we're using these open and closing squigglies to say put our variable or display it in here, and our caller. The caller is the person who tried to, or who did access this function. Okay. Now we don't necessarily need to pass it a value, but I have. Now we can also set a second, and I recommend you always do this, parameter. Okay, so this is a named parameter, so we need to say target, semicolon, and then we can give it any kind of target name we want. So I could call this, I am Eric, and what this is going to allow us to do is filter, by group, which error messages we want to receive, okay? Because if we set up a lot of error messages throughout the system, we may not want all of them all the time. We want to filter through. And if we don't set up a custom error message, then it's going to use the palette's name as the target. And I really recommend you don't do this because it can be sort of hard to hook onto that, just depending on how good your typing is, okay? So I want to actually look at this. We're going to run this and then see how we can access this. And hopefully I won't have any compiler errors because I've been playing around with all of this. Let's go ahead and save this. And I'm going to open up my terminal just here at the bottom, right? And I made a couple of notes here about how we can call this. And I am going to use this method here to call it if you need to check back, okay? So let's do this. We're going to say cargo run -- bin. We're selecting the binary that we're running because there's more than one. Kitchen - node. Then I am going to pass it to the actual binary some value. So I have to say -- space -- dev -- temp. So this is for a development version, and we wanted to create everything into a temp file. Now we need to pass it another parameter. So I'm going to say dash L for logging. Okay, now I'm going to give it the name of the target that I want to check. Okay, so I want to check, for example, say this custom messages. So it's going to be all one word, L custom messages. Okay, and make sure you don't misspell this as case sensitive, equals, and the level that I want is at least to the debug level. Now I'm going to hit enter, and I'm probably going to need to compile for a minute if I didn't get any typing errors there. Okay, so it has compiled, and you can see I've got some info statements and some warning statements that you may not normally see because we have the debug turned on. Okay, and in order to get our messages here, though, we actually have to call this function. So we're going to do that. And let's look at the function name. So we want to call this runtime WASM function, and maybe we can also call this say hello function and just see what happens. So to do that, we're going to go over to Polkadot here. And please watch an earlier video if you're not sure how to set up the polkadot.js.org for this. And don't forget to refresh it if you still have it open from last time, because it will be looking, so it's something that's not there. So we're going to go ahead and go developer extrinsics, because we're going to call something, like we said, from off the chain onto the chain. We can select any user we want, just for test. Now we want to select the name of the palette that we're going to use. So what was the name of this? Was hello substrate is the name of the palette. And the function that we want to call is called runtime WASM. It gives us the option. And there's no other options that we can add because it doesn't take any parameters other than origin. And this is sent automatically. The origin here is Bob. So we're going to go submit transaction, submit and sign. And now we want to go back to our node and see what's happened here. And you can see here we have an error, a warning, and info. And you know what? Maybe I spelled it wrong. Let's take a look. Okay, so we have an error, a warning, and an info that is set here. So those got called. But we did not get the debug because the debug's target was set as something else. Okay, and we also didn't get trace because trace is a higher level than debug. Let's just go back and let's call our say hello function and see what happens. And you know what? I'm not sure if this will call anything, and no, it didn't, because it's just not, the flag is not set here to use the print statement. Again, unless there's a very specific reason why you need to use the print statement, I would just move away from it and go to these debugs. Okay, so I'm going to go Control C to stop this, and we're going to look at this a little more in detail. Okay, so I'm just going to change here the target to this one is custom messages, so we can see it in the future maybe. Okay, now why did I call this function runtime WASM? And it's because right here, I added an extra statement, and this is a set statement, so there's no way for you to sort of guess it if you don't know it, so you would have to look it up or something. But if we say debug, runtime logger, init, what it's going to do is, even in the WASM version of this, not just the native version, it's going to call all of these debug statements. And generally speaking, this is not something you want to happen. You don't want all your debug statements to happen in a WASM in a real runtime environment. We just want this for testing, okay? But if for some reason you absolutely do need it, then you need to call this first for it to show up in WASM. So for the most part, we're not actually going to be using it this way. So how are we going to be using it? Well, I have another function here, and this function is called say less overhead. And what this is it's going to be printing to the node log, but it's going to be skipping the WASM and only be running for native and it looks very, very similar. The only difference here is instead of saying debug, little doubly dots here, debug, or debug little doubly dots warn, we're going to add an extra submodule in here that says native. Okay, so we're going to say debug instead of just to like warn here like this. Okay, we don't want this. We're going to say debug, use the native submodule and warn like this, and call it this way. Okay, so we're only going to call it in the native. So here, this was from the documentation. The frame supports debug native debug. Macro avoids extra overhead in WASM runtimes, but is only effective when the runtime is executing in native mode. So for us, this is just during development, okay? So again, we also don't need this init statement, right? We don't need this debug runtime logger init because we don't want it to run in WASM. So I gave these all the target as just the word native. So we have 2 warnings here, so I can just like knock one of these out here. And there is actually more than one way to show these. So let's go ahead and just do the same. Run this first. I don't know how well you can see this down here, but it says cargo run -- bin, right? Just put like before space, kitchen -node -- because we want to pass values to the binary, which is --dev --temp. Then I'm going to go --l, or sorry, only one dash. It's a little tricky for me. 1-l for logger. Then I'm going to say native. Then I'm going to say equals debug, and I'm going to double check this with my eyeballs. Okay, it looks right, and hit enter. Okay, so here's the thing with this. If you mistype the name of the palette, or not the name of the palette, the target here, like maybe I have native with a capital N or it has an S at the end, it's actually still going to run the debugger at the lower level. Like it's still going to show the info, it's still going to show the warning and all that kind of information. Just the very basic low-level stuff, but it will not show debug or above. I'm not sure why that is, but if you misspell it, it's not going to activate this palette's debug, but it is going to turn on sort of a low-level debug mode, and you're going to see it. So sometimes it's hard to miss, because if you like mistype it and you don't realize it, and you think, oh, like I'm seeing all these, statements that I don't normally see, the info statements and the warning statements, just double check what you wrote, okay? And I'll show you one more way to do this, and we'll look at this in a minute, but I also have it here just in the comments. But if you put rust_log equals runtime equals debug, okay, and this could be rust_log equals, and then whatever level you want, it could be trace, it could be debug, whatever. Then all your commands, it's going to run debug on the whole system's debug. So you're going to end up with like a ton of logs. But if you're having all kinds of problems with Substrate and you need to like dig deep into the systems to find out what's going on, you can use this rust_log equals debug, and we'll see more information about that. Okay, so now this is running. Let's go back to Polkadot.js one more time. Refresh this. And again, we're on the extrinsics because we want to call a function. And my function is still hello world. Or sorry, hello substrate. And we're going to call this one so it's less overhead. Let's submit this transaction. And go back to IntelliJ here. And you can see here we have a debug and a warn statement, which is just like from here, and it says this this debug message is not native. Actually, it is native. I don't know why it says that, but this is for native. Okay, so these two were called. And again, if we misspelled it, we wouldn't have this debug statement. Okay, so let's just do Control-C again one more time to stop this, and let's look at just running the system wide Rust log here. So we're going to go rust_log all in capitals, and let's just try equals debug. Oh, I have a rust Rust underscore. I'm not sure what the difference here is between the runtime debug and just the normal debug, but let's just try it. Let's do debug. Now we need to type out the whole thing again. So cargo run dash dash bin space kitchen node space dash 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 dev dash dash temp, and let's throw that on. Now, if I did that right, okay, so you can see here there's like a ton of debug statements and like all kinds of stuff here that you may not need. I don't even need to call any functions to trigger anything because these are all things that are just happening on their own. But again, if you need to debug this and you need to dig a little bit deeper, you can do this by just throwing on the Rust debug, okay? So let me just Control C this to stop. So again, just a little recap here at the end, because we went over quite a bit. And I won't go over the module parts because we're going to go over this in a whole bunch of different sections. You're going to go over it and over and over and over it because they're really repetitive. So if you haven't like memorized it right at the beginning, that's okay. It's something that you're going to see a lot of. So let's just jump down to the actual debug statement. So again, I'm not using this print statement. According to the documentation that I found, that this is legacy, so it still works, you know, if you do it right, but that you should maybe be moving away from that. So if we want it to run in WASM, which does create some overhead, so this is only if you have a very specific reason for it, we need to use the debug runtime logger init statement. And then when we use the debug statement, we need to use debug ... info or debug or error, whatever it may be, without the native between it, okay? So we can pass a variable in here to print out, but we should also remember to add a target so we can target this, okay? Just like so. Like this. So even if we have a variable being passed, we can still set the target. Okay, and lastly, or almost lastly, we want to typically run this with a lot less overhead by not using the WASM, which means we're going to go debug native and then our error level and then pass the parameters there. And again, to actually show it, we're going to use pass the argument in the command line -L for logger, then the name of the target that we set equals debug or whatever level and below that we want to show. So as you saw, it's just going to set the debug for that palette, or not that palette, but for that target rather than for like the entire substrate runtime, which might, you know, just drown out everything that we actually want to see. So then we have to go ahead and go to Polkadot.js and actually fire off the extrinsic, which is we're gonna call our function specifically, and then we're gonna see our message here in the log. So in this way, we can pass debug values to ourselves in the node log here, and hopefully if you're having troubles with things, maybe this helps so you can just, you know, essentially have a you know, a print statement or a console.log or whatever programming language you come from. You know, this is debugging 101. Okay, so that was a large, long part because we looked at our very first palette of Hello Substrate. And in the next part, you know, come back, we're going to go over the next palette and look even a little more deeper. Okay, until next time.